So now we are going to discuss about the nomenclature of heterocyclic compounds. See, usually organic compounds we will follow the nomenclature to give the naming. Similarly, for heterocyclic compound also we are giving numbers and namings for the heterocyclic compounds. So in case of heterocyclic compound, we should give the preference in such a way the heteroatom should get the first number. For example, this is the structure of furan. So here we have to start the numbering first to oxygen, then we can give the numbering to the other atoms. So here we are giving the numbering to the oxygen, that is a heteroatom first. So the heteroatom should get the least number. So in case of two heteroatoms are present, then we have to follow the same way. That is, for example, imidazole. This is the structure of imidazole. Here we have to give the numbering in such a way the heteroatom should get the least number. So this is the numbering pattern of the imidazole. So two nitrogen atoms are present. So this one nitrogen is present in the first position, and the second nitrogen will be present in the third position. If you are following the clockwise direction, then the second nitrogen will get the fourth number. So you should not follow like that. So it should get the least number. So another one problem will arise. That is, if different types of heteroatom is present, means how can we write that? For example, we will see the structure of oxazole. So this is the structure of oxazole. Here oxygen is present as well as nitrogen is present. So if two different heteroatoms are present, means then we have to follow one rule. That is, according to the atomic number, we have to give the preference. The oxygen which is having the highest atomic number than nitrogen. So oxygen will get the first preference. So this is the numbering pattern of the oxygen. Then, if a 5-member ring is containing a heteroatom, then it will end with the suffix OLE. For example, if you see the structure of pyrrole, here it is having a 5-member ring, nitrogen is present. So if nitrogen is present, means this suffix will be there. So it is called as pyrrole. So this one is called as two nitrogen atoms are present. So nitrogen is present in a 5-member ring, then it will end with the suffix OLD. So these are all the two examples. One is pyrrole, another one is imidazole. Two nitrogen atoms are present. It is end with the suffix OLE. So pyrrole and imidazole. In case of 6-member ring, if 6-member ring is present that contains nitrogen, means it will end with the suffix INE. It will end with the suffix INE. So this is the example of the 6-member ring with one nitrogen atom. Example will be pyridine. This one is another one example, pyrazine. So both these compounds are having the suffix INE. So pyridine, pyrazine. See, in case of 5-member ring, if one of the bond is here, I have drawn the structure of pyrrole. If one of the bond is becoming saturated, then it will end with the suffix INE. So here I have drawn the picture of pyrrole. This pyrrole, if one of the bond is becoming saturated, then it is called as pyrrole. If both the bonds are becoming saturated, then it is called as pyrrolidine. So here I have drawn the picture of pyrrole. This is the structure of pyrrolene. Here one bond is becoming saturated, then it is called as pyrrolene. And here both the bonds are, both double bonds are becoming saturated, then it is called as pyrrolene. So if both the bonds are becoming saturated, then it will end with the suffix INE. So in addition to that, we have to, if it is a fused ring system, then we will take the basic nucleus. For example, here benzene is fused with the imidazole. So this benzene is fused with the imidazole. So for naming this heterocyclic compound, we have to select the basic nucleus. Benzene is the basic nucleus that has been fused with the imidazole. So we will select the compound name in such a way, benz imidazole.